Okay, so clearly a theme from this set of talks is that host galaxies are important. Anyone want to take a counter opinion on that? Lynn?
So I have a question for Anya. So the metallicity of host galaxies clearly is really important parameter in distinguishing these types of transient. The question is, does your code Frankenblast infer metallicity directly from photometry, or do you need spectra actually to do this properly?
It's definitely best to use spectra, but we do infer stellar metallicities directly from photometry. So are they the most accurate? Probably not, but it can give you a good indication of how metal-rich different transient populations might be in comparison to each other. Like we certainly saw that type 1a supernova were occurring in more metal-rich galaxies than core collapse populations, which is the expected relation.
Do you get an uncertainty on that metallicity in France?
Of course, yes. That's the whole point of using SBI++, is that you
exactly.
get well understood, robust posterior distributions.
Yeah. Good. Okay.
Slightly changed topics, but it's something I wanted to bring up.
Yeah, please.
So for the Otter, one thing that I want to encourage all of you to bother me or Noah about is how do you actually plan on using the Otter, right? Specifically, if you want to do a study on, say, nuclear transients, TDEs, AGN, whatever, you go into the website and you're like, give me a list of objects I am interested in for which the data has already been cleaned. But how do you define that sample? Because as we've learned, there's a lot of ambiguity in how we classify things. Do you want a pure sample? Do you want a complete sample? And that is going to inform how we structure the database, right? And we will motivate how we structure the database based on how you expect to use the Otter and how we can best help you to do that. We don't want to be the police of like classifying objects and say, oh, no, this is a TDE, it's not an AGN, because we say so. No, we don't want to be that. We just want to aggregate all of the community input and find out the best way to deliver it to you depending on what you want to do.
So, I mean, I'll pitch in as chair.
Yeah.
Do you, one way of getting feedback is you set something up and then you just listen to how everyone complains about how bad it is and adjust accordingly, rather than, sort of build it, rather than soliciting, designed by committee is always famously bad.
Yes.
I guess also related to that, we do have a Slack workspace and it's linked on our documentation, which is linked on the website. So if you want to give us feedback, please join that and tell us how bad it is.
Or how good it is. I've actually already used it, so I quite like Otter. Yep. Griffin.
Let me respond to your point, Sebastian. So like, okay, on the TNS, if you reclassify something, you're overwriting the previous classification. But in the old Open Supernova catalog, you could have multiple classifications. So I imagine you should just allow everybody to put whatever they want in there. And then as someone's querying it, they can say, they can either say, give me everything that has only a TDE classification, or give me everything that has at least a TDE classification, right? Is that, okay, perfect.
I think actually those reclassifications can be important because it can infirm things down the line, give us all objects previously known as prints.
Yeah, I guess the broader point is like you have all of the uncertainty in there and then people can use it however they see fit.
And I think, one of the things that came up yesterday as well was this idea of reproducibility. And so if I know something was classified as something because of a thing a while back, being able to reproduce that misclassification may help me with something that I'm uncertain about. And it's an edge case, but I think it's still important for this sort of stuff. Are there products from Rubin Roman that we think are going to be most useful when they're used together in this sort of wavelength sense?
This was another response to Sebastian's
sure.
question. Sorry, and then you can move on. Is that there's like a lot of very classic metrics. I'm thinking of like the first ZTF sample of TDEs has all these plots that compare TDEs to other transients. And it might be nice to just have these really easily accessible within Otter, is to have the entire space of G minus R color evolution for all the TDEs, and then overlay the TDE you're looking at and see like how TDE like is this, you know, in terms of classifications. Obviously, once you move to other transients, it's going to be a lot harder, but that's one thing that everybody can do, skim and really easily evaluate.
Yeah, I certainly know in the stellar world that having the HR diagram in your interface and seeing where things lie on the stellar on that is a really useful diagnostic. And I think that in the transient worlds, we haven't yet defined what our characterizing diagrams are, apart from maybe rise time and energy or something like that. But actually having something like that, we maybe think as a useful diagnostic for people who are putting sites up like Otter and things like that.
Yes, I had a question for Anya and Noah and anyone else that's kind of building infrastructure that could incorporate host galaxy associations. But I was curious at the depths of Rubin and Roman, are you expecting it to often come up where there's kind of an ambiguous host association, and you could maybe fold it into the infrastructure where there are, these 3 potential hosts. Here's the Frankenblast modeling. Here's a probability that this is the host, that sort of thing.
So this is why Prost is so cool, is that it gives you the first and definitely the second best hosts that it's found. And so that's definitely something we would be able to incorporate.
Does it give you the worst host?
Oh, no. Well, okay. But it's like looking over.
No.
large
I mean,
area.
but it because that can often give you a range. If this is the worst host it could be, that could be informative for interpretation.
Sure, but I think that's dependent on your search radius. But it will tell you like how probable the host association is. And then it also gives you, if it thinks that you could actually be associated to a host galaxy, that the catalog, like you can't detect the host in the catalog, or if it's outside your search radius. So there's like a bunch of cool parameters in there, which we can use.
Oh, that's really useful. Yes. Nancy.
So more in host galaxies. I have 2 questions. The first is for Anya, which is how scalable is easy? I mean, you said Frankenblast was 15 minutes per galaxy. Can easy be run on entire streams, right? Or that's the first part, then I'll ask the second part.
Yeah, easy's way faster. So I think for that data set that I was showing, it took like maybe less than a second to do 100 photo Z fits. So it's really fast. And I think the way that in which I'm envisioning things is that we use something like Easy, which is very widely used by the Galaxy community and can fit out to very high redshifts. And then we feed that photometric redshift into something like Frankenblast to speed up the fit there. I think that would be a cool way to do things just because it's so much faster. But then maybe that's also beneficial for the rapid alerts if you want a very fast photo Z estimate in there.
So what is, thank you, that's fantastic. What is the state of the art in photo Zs, right? I mean, if you had infinite time, how accurate a photo Z could you get to how high a redshift, right? If you're talking to galaxies people, I think there are some galaxies people, not a lot, but some in the audience.
So Easy can robustly infer photo Zs out to about a redshift of 6. There are a few ML-based photo Z estimators for Rubin data and for DES, but from my understanding, those are only good to about like redshift 0.5. I haven't really played around with them too much yet. It's something that we can consider, but I don't know that they work with both like Rubin data and Roman data. And so I think that we need to consider how we want to use all of this data together. And that's probably something that I should look into, is just playing around with all these codes and seeing how well we do and which one is best optimized for the science that we're trying to achieve.
Yes. Sadly, Gautam has left the room. Otherwise, he would be a good person to answer that because he's the spokesperson for the dark energy. And I think they're, yeah, good. We are at time actually, and we still have many things to do before your lunch break. So let's thank all the discussion.